Is 7.6 quadratic transformations. Okay, I've got a transformer on here because we're talking about transformations. All right, so transformations, if you remember from linear, is how you take the parent function, which was y equal x, and then you saw how putting numbers in front and behind and the m and the b changes what happens to that graph. So those are transformations. Now we're going to be doing the same thing with quadratics. So just a few things you need to take notes on. The parent function of a quadratic function is y equals x squared. Now this is in function notation, but it's the same thing as y equals x squared. Now, transformations change the size and position of a figure. Okay, and we saw that with linear also. So these are the types of transformations we'll be looking at. We have a translation, and that means that we can move the parabola up or down. We could slide it left or right. And then the next one is a reflection. And this is the one where it actually flips the opposite direction. So if it's pointing upward, then it would be opening downward on a reflection. And then the next one is going to be stretches or compressions. And those occur when the x or y values are multiplied by a factor. So we're going to see what all these are. Now, when finding the transformation of quadratic functions, we look at how the x and y values of the function have changed. Okay, we look at f of x being replaced with one of these on the following. If we take f of x and on the inside of the parentheses, we subtract a number, that's going to make a transformation happen. And if we take f of x and the y-intercept is actually 0, but then we add some number over here or subtract some number, that's going to change my equation, my function. If I put a number out in front of f of x, it's going to change. It's going to cause something to happen. And if I put something in front of the x, it's going to cause something to happen. So our job today is to be able to explore all these different scenarios and find out how that graph is changing from the parent function. All right, so now we're going to talk first about vertical translations. That means shifting up and shifting down. And so what we're going to do is we're going to graph the parent function first. And the best way for us to do that is to use Desmos, right? We're going to be comparing and contrasting these. And so I'm going to go first, and I'm going to type in f of x equals x squared. Okay, that's my parent function. And we see what that looks like, right? We've been working with that for a while. That's going to be the red one. Now on the second line, let's go ahead and graph f of x equals x squared 3. Okay, so what changed is this k. If we have a positive case, something happens. If we have a negative case, something happens. In this case, we have a positive k. We're going plus 3, right? Plus 3. And so let's take a look and see what happened there. And so I'm going to turn this one off, and I have the red here showing the parent function. Looks like it goes through 0. And then this one, what happened? Well, it just shifted up 3 units. We were at 0, now we're at 3. So we would say, let's answer some questions about this. And so it says, what do you notice is different? The parabola is higher, right? It shifted up. And so how does the change on the graph relate to the change in the equation of the parent function? In other words, how is this graph different from this one, okay? Well, it's different because when the k is positive, the graph shifts up that many units. And so if you would just start making yourself a list of these transformations, I would say when k is positive, the graph shifts up that many units, or k units. Remember, you can pause this video anytime you need to, but for the purpose of the length of the video, I'm going to keep going. All right, good. So now, we could also say that if k is negative, it would make it shift down that many units. So let's check that to be sure. And so here I've got a plus k. But let's see what happens if I make that a minus k. It went from 0 to negative 3. And so you can see that this is shifting it up or down depending on what value of that k is. All right, fantastic. All right, let's go to this one. I want you to pause the video. I want you to try this on your own. And I want you to tell me what is going to happen to each one of these scenarios. All right. So now that you're back, you should have looked at each one. Now you should be able to know automatically. When you look and see that your k is a negative 4, you should know that that's going to shift down 4 units. And so let me take a look at that and see. If I do minus 4, and you can see that the blue line is down 4 units from the other one. So this one started at 0, 0, and this one ends at 0, negative 4. So that's a shift down of 4 units. The other one is a plus 7, and if you said it shifts up 7 units, you were correct. And so you can see on this one that it actually shifts up to the 7, right, from 0 to 7. So those are my transformations on there. All right, so that's your first transformations of K. Now let's talk about horizontal translations. This is what happens if we take f of x and we add a number inside the parentheses, or we subtract a number inside the parentheses. So we're going to do f of x equal x squared first, and then we're going to go type in f of x equals x plus 2 squared. Okay, so let's go take a look at that and see what we get. So I'm going to go ahead and leave this one in there. And in this case, I'm going to type in f of x equals, and in parentheses, I'm going to do x plus 2 and then squared. Okay, so when I look at that green one, what happened? There's the red, there's the green. It looks like it shifted to the left 2 units. Now remember, we've talked all year long about things in parentheses tend to do the opposites. So since this is a positive 2, it's moving to the left 2. It's going the opposite direction you would think. So in these horizontal translations, if it's a positive h, it's going to go left. If it's a negative h, it will go right. Just like right here, if I put in x minus 2 squared, you can see it shifted to the right. Okay? All right. Now, let's answer the questions. Make sure we got this down. So what do you notice is different? It shifted to the left. And then how does the change on the graph relate to the change in the equation of the parent function? It's going to be left 2 units. And so these are next 2 rules you need to write down. If the h is a negative, it's going to go to the right. And if h is a positive, it's going to go to the left. And you might make a little note on there that talks about inside the parentheses, it does opposite. Okay, so now let's try these 2. You should be able to look at it. The goal here on transformations is to be able to look at the equation they give you, compare it to the parent function, and know what's happening. So you know this is h. It's on the inside. So it's minus 3. So this is going to shift to the right 3 units. Remember, it goes the opposite. And this one is a plus 4, so it's going to shift to the left 4 units. Now, you can always take these in there and check them. So let me try this x plus 4 first. And you can see it shifted to the left. And now let me go in there and try the minus 3. And you can see that it shifted to the right. Okay? So there's your next 2 rules. Okay, so we talked about the translations, moving up and down, and the horizontal shifts left and right. Now let's talk about reflections. This is the exact same rule we had when we did linear. Okay, when a is negative, it's going to reflect the opposite direction of the parent function. And so I'm going to go and show you that in Desmos. And so let me get rid of this. And I'm going to put the parent function is the red one. And then right here, I'm going to turn this to a negative. Okay, I don't need these parentheses anymore. And you can see what happened here. And so the red one is the parent function. And then since we turned that negative, it actually made it shift upside down. Okay, so now what do you notice is different? The parabola reflects across the x-axis. And then how does it relate? Well, when a is negative, the graph reflects across the x-axis. That's your new rule. So if a is positive, it's pointing upward. If a is negative, then it is pointing downward. Okay, a little bit of memorizing in this, right? Now we're going to start mixing some of these together because you should know several of these rules now. We have 5 rules. Let's see what we can see happening. So in this one, I see that I have a negative up front. My a is negative. So we know that's a reflection. And then we have a plus 4 on the outside. That means it's going to go up 4. So let's check that and make sure that we are right. And so I got negative x squared plus 4. Okay, and I can type that in just like it says. It's fine. You can do negative f of x plus 4. Oh, and make sure you do, yeah, just do, that should be x squared. Okay, so you got negative x squared plus 4, and you can see what happened. It reflected because of the negative, but then also your y-intercept was at 0, now it's at 4. And so you have that shift up and that reflection, 2 things happening. Okay, so there's your 2 transformation. Now this one, what happens when you have a negative out front? Well, when you have a negative out front, remember it's going to reflect. what happens when you have a -1 in the parentheses? That's going to shift to the right that many units. So this one should be a reflection and shifted to the right. So let's check it. So I'm going to go here, and then I'm going to go -1, close my parentheses. Let me get rid of the stuff on the outside. And now I got negative times x minus 1 squared, and you can see that this is shifted to the right 1 unit, and it's reflected upside down. All right, good. All right. Now, the next set of rules is that you have vertical stretches and vertical compressions. And so we're going to do vertical stretches first. A vertical stretch is what we would say is getting, well, since it's a vertical stretch, it's going towards the y-axis, okay? So it's going to be getting skinnier towards the y-axis. And so I want to see what that looks like in Desmos before we do anything else. And so I'm going to go in here and I'm going to type in 2. If it'll let me do f of x. I don't think it will. It does. So I can just go in here and just type in f of x equal x squared, and then just type 2f of x, and it will actually graph both those for me. And so you can see what's happening on this graph. What's happening is it's taking these two and it is stretching it towards the y-axis. And so we would call this a vertical stretch up and down. So it's stretching it towards the y-axis. The bigger this number gets, if I do 9, you see how much it stretched there? If I do 900, it really stretches. Okay, so the bigger the number, the more it's going to stretch. And so we would say that the rule on this is going to be that when the A is bigger than 1, the graph stretches vertically by that much. Okay, let's talk about vertical compressions. If stretches are this way, right, it's stretching up. Let me go in here and put in that other one I had. Let's do 2f of x so I can see the green one there is skinnier, right? Now let's talk about a vertical compression. What happens when I turn this to a 1/2? So if I do 1/2 f of x, now you can see that this purple line, let me turn off the green one. The purple line it looks like it's wider than the parent function. That's because we are compressing it away from the y-axis. So a fraction on the outside is going to push that graph down away from the y-axis. Okay, that would be a compression. All right, and so when you see these, you can see the red line is the parent function. If the number is bigger than 1, like 2, it's going to vertically stretch it. And if it's a fraction, it's going to vertically compress it. Okay, so that would be our rule on that one. Is that when the A is a fraction or a decimal less than 1, then the graph compresses vertically by a factor of A. Okay, so I want you to try these two. You should be able to look at them and kind of tell me what's happening. If not, put them in Desmos and then make sure you understand what's happening on that. Okay, so if you did that in your back, then you would see that this is a fraction smaller than 1 out front. So this is going to be a vertical compression. It's pushing away. And on this one, we see we have a 4 out front. And so that means it's going to be a vertical stretch. But we also have a +4 on the outside. In my K, if you recall, that means we shifted up 4. So this would be a vertical stretch, and then it shifted up 4 units. Like I said, it's a lot, but this is the thing you have to memorize, okay? You have to just study these steps and make sure you have them down so you can see these equations and know what's happening. Okay, so now let's go and look at this one, a horizontal compression. We just saw a vertical compression. Now, horizontal compression, it looks a lot like a vertical stretch, all right? And that's where it kind of gets confusing. But you can see the number is in front of x, but on the inside of the parentheses, okay? And remember, on the inside of parentheses, usually things are the opposites. And so I'm going to do f of 2 of x, and you can see what happens here. And so what this is doing, it looks like a vertical stretch, right? But it's in reference to the x-axis. So this line would be a vertical stretch if we were pulling it towards the y-axis. But that's not what's happening here. We are actually compressing this away from the x-axis. And so this is a compression away from this axis. It's going away from it. And so it's the opposite of a vertical stretch, a vertical compression. Okay? So we would say that if the number is in front of x, if the B is numbered is greater than 1, then the graph would compress horizontally by that number. All right. We're going to put all these together at the end, and then we'll get practice on this. You'll start figuring this out. All right, now let's go do the same thing. Instead of having a 2 there, I'm going to go down to the bottom. Let me turn this one off. I'm going to do f of 1/2 x. Okay, so we can see that one that they gave me right here. This is a horizontal stretch. Now remember, horizontal is the x-axis. So it's saying it's stretching it towards the x-axis. If I took these two lines on the parent function, let me change that color. I don't like confusion with that. Okay, so look at the red one. That's the parent function. If I grab those two lines and I stretched it towards the x-axis horizontally, then you can see that would be a stretch. Now, if it was going the other way towards the y-axis, this would be a compression, right? And they're opposites. Remember, in parentheses, they do the opposite. And so the rule that we could say on this one would be that when the b is a fraction, smaller than 1, the graph reflects horizontally by a factor of b. Okay, so I want you to try these two. Just kind of look at them, see if you can figure out what's happening there by looking at your rules. Okay, go ahead and pause and do that. Okay, now that you're back, so let's compare that. So this is on the inside, right? So this is a number that is bigger than 1. And so if this was on the outside, this would be a vertical stretch, right? Since it's on the inside, it's going to be a horizontal compression. Horizontal compression. And this one is a fraction that's on the inside. And so normally if it's on the outside, that would be a vertical